The Electrician's Exam Preparation Guide, 7th edition, is a recommended starting point. It comprehensively covers the topics necessary for the journeyman electrician exam. Its clear and concise writing style facilitates easy understanding. After mastering the fundamentals in this book, move on to more advanced subjects such as electrical codes and electrical design. Consider these books as well. Firstly, Electrical Wiring Residential, 18th edition, by Ray C. Mullen. Secondly, Ugly's Electrical References, 2023 edition, by Charles R. Miller. Thirdly, the National Electrical Code Handbook, 2023, by Mark W. Early. These resources can further enhance the understanding of the field. It is important to understand fundamental electrical concepts to be successful in the field. Consider voltage, current, resistance, and power. Voltage, measured in volts, is the electrical potential difference between 2 points in a circuit. It is the driving force that pushes electrons through the circuit. Current, measured in amps, is the rate of flow of electric charge through a circuit. It is the amount of charge that passes a given point in the circuit per unit of time. Resistance, measured in ohms, is the opposition to the flow of current in a circuit. It is a property of the material that the current is flowing through. Power, measured in watts, is the rate at which electrical energy is transferred in a circuit. It is the product of voltage and current. Ohm's law describes the relationship between voltage, current, and resistance. It states that voltage equals current times resistance, or volts equals amps times ohms. This fundamental law is essential for analyzing and designing electrical circuits. Understanding series and parallel circuits is critical. In a series circuit, components are connected end to end, so the same current flows through each component. The total resistance in a series circuit is the sum of the individual resistances. In a parallel circuit, components are connected side by side, so the voltage across each component is the same. The total resistance in a parallel circuit is less than the smallest individual resistance. Understanding electrical safety is essential. Always de-energize circuits before working on them. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards of electricity, such as shock and arc flash. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment. It is important to be familiar with the NEC and to follow its requirements when working on electrical systems. The NEC is updated every 3 years, so it is important to use the latest edition. Grounding is a critical safety measure in electrical systems. Grounding provides a low resistance path for fault current to flow back to the source, which helps to protect people from electric shock. The grounding system consists of a grounding electrode, a grounding conductor, and equipment grounding conductors. The grounding electrode is typically a metal rod or plate that is buried in the earth. The grounding conductor connects the grounding electrode to the neutral point of the electrical system. Equipment grounding conductors connect the metal enclosures of electrical equipment to the grounding system. Bonding is another important safety measure in electrical systems. Bonding connects all of the metal parts of an electrical system together to create a low impedance path for fault current to flow. Bonding helps to reduce the risk of electric shock and fire. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. These devices are designed to trap and interrupt the flow of current when the current exceeds a safe level. Circuit breakers are resettable, while fuses must be replaced after they trip. It is important to select the correct size overcurrent protection device for the circuit being protected. Wiring methods are the different ways of installing electrical wiring. Common wiring methods include conduit, cable, and surface raceway. Conduit is a metal or plastic pipe that is used to protect and route electrical wiring. Cable is a factory assembly of 2 or more conductors that are insulated and enclosed in a sheath. Surface raceway is a metal or plastic channel that is mounted on a surface and used to route electrical wiring. Boxes and fittings are used to connect and support electrical wiring and equipment. Boxes are enclosures that are used to house electrical connections. Fittings are devices that are used to connect conduit, cable, and other wiring components. It is important to use the correct type of box and fitting for the application. Conductors are the wires that carry electrical current. Conductors are typically made of copper or aluminum. The size of a conductor is determined by the amount of current it is expected to carry. The insulation on a conductor is used to prevent the conductor from coming into contact with other conductors or grounded surfaces. Terminations are the points where conductors are connected to electrical equipment. Terminations must be made properly to ensure a reliable electrical connection. Common types of terminations include wire connectors, lugs, and terminal blocks. Electrical drawings are used to represent electrical systems. Electrical drawings typically show the location of electrical equipment, the wiring connections, and the circuit protection devices. It is important to be able to read and understand electrical drawings. Electrical testing equipment is used to measure electrical quantities such as voltage, current, and resistance. Common types of electrical testing equipment include multimeters, clamp-on ammeters, and insulation testers. It is important to know how to use electrical testing equipment safely and accurately. Troubleshooting is the process of identifying and correcting electrical problems. Troubleshooting typically involves using electrical testing equipment to measure electrical quantities and to identify the source of the problem. It is important to have a systematic approach to troubleshooting. Electrical codes and standards are constantly evolving. It is important to stay up to date on the latest codes and standards to ensure that electrical systems are installed and maintained safely and correctly. Professional development is essential for electricians. There are many opportunities for electricians to continue their education and to learn new skills. These opportunities include apprenticeships, continuing education courses, and certifications. Consider Article 90.1 of the NEC, which states that the purpose of this code is the practical safeguarding of persons and property from hazards arising from the use of electricity. NEC Section 110.3. B. Installation and use requires that listed or labeled equipment be installed and used in accordance with any instructions included in the listing or labeling. NEC Article 210.12. It states that all 120-volt, single-phase, 15-ampere and 20-ampere branch circuits supplying outlets or devices installed in dwelling units must be protected by arc fault circuit interrupter or PSI protection. NEC Article 250.4. A1 adequately covers the grounding requirements. The NEC also covers the requirements for ground fault circuit interrupter or GFCI protection in Article 210.8. These are just a few examples of the many requirements in the NEC that electricians must be familiar with. Another important aspect of electrical work is understanding the different types of electrical equipment and their applications. Transformers are used to step up or step down voltage. Motors are used to convert electrical energy into mechanical energy. Generators are used to convert mechanical energy into electrical energy. Lighting fixtures are used to provide illumination. Heating elements are used to convert electrical energy into heat. Control panels are used to control electrical equipment. Understanding how these different types of equipment work is essential for electricians. Effective communication is also crucial for electricians. Electricians must be able to communicate effectively with other tradespeople, engineers, and customers. They must be able to explain complex electrical concepts in a clear and concise manner. They must also be able to listen carefully to the needs of their customers and to provide them with the best possible service. Time management is another important skill for electricians. Electricians often work on multiple projects simultaneously. They must be able to prioritize their tasks and to manage their time effectively in order to meet deadlines. Problem-solving skills are also essential for electricians. Electricians are often faced with unexpected problems. They must be able to think critically and to develop creative solutions to these problems. Adaptability is also an important trait for electricians. The electrical industry is constantly changing. Electricians must be able to adapt to new technologies and to new methods of doing things. For example, Table 310.15. B16 in the NEC provides ampacity ratings for conductors. Ampacity is the maximum current, in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The table lists ampacity values for different conductor sizes and insulation types, based on an ambient temperature of 30 degrees Celsius and no more than 3 current-carrying conductors in a raceway or cable. Correction factors are applied when the ambient temperature is higher than 30 degrees Celsius or when there are more than 3 current-carrying conductors in a raceway or cable. These correction factors reduce the allowable ampacity of the conductor to prevent overheating and insulation damage. For example, if a conductor with an ampacity of 30 amps at 30 degrees Celsius is installed in an ambient temperature of 40 degrees Celsius, a correction factor of 0.88 may be applied, reducing the allowable ampacity to 26.4 amps. Similarly, derating factors are applied when there are more than 3 current-carrying conductors in a raceway or cable. These factors also reduce the allowable ampacity of the conductors to prevent overheating. For example, if there are 7 to 9 current-carrying conductors in a raceway or cable, a derating factor of 0.70 may be applied, reducing the allowable ampacity of each conductor to 70% of its original value. These tables and correction factors are essential for ensuring the safe and reliable operation of electrical systems. They help electricians select the appropriate conductor sizes for specific applications and prevent overloading of conductors, which can lead to overheating, insulation damage, and potentially fire hazards.